Hello everyone. In today's lesson, we will continue our topic indices. We have already learned about the two index laws. One is the index law of multiplication, which is a to the power m times a to the power n is equal to a to the power of m plus n. And the second law we worked on is a to the power m divided by a raised to the power n is equals to a to the power of m minus n. Now, the third law of indices, which we are going to learn in today's lesson, is power of power expression. Power of power expression. So, what it says, if we take a power expression and then we take another power of it, power raised to the power, then here these two exponent values will be multiplied together and this will become a raised to the power mn. This rule will be used both ways. Some cases we will use it the way a to the power m and whole raised to the power n is given, so we will make it a to the power of mn. And sometimes we will use this a times a to the power of mn as a to the power m whole raised to the power n. And mainly we will be using this case when we have m into n as a fractional value. Okay, so this concept I will explain in detail at that time. But remember, this is a very important property when you have the fractional units. Okay, now the question, the fractional units, which will be non-unit fractions. I will explain all these things there. All right. So now, for example, let's take some examples here for this property. We have a raised to the power of 5 and whole raised to the power of 3. So basically, if I expand it, this is a to the power and whole raised to the power 3. So it is a to the power 5 times a to the power 5 times a to the power of 5. That is the meaning of this 3. Now, because these are the power expressions with the same basis in multiplication, so the exponent values will be added. This multiplication law is not restricted to only two power expressions. It can be applied to multiple power expressions. So this will become a to the power of 15, and which is like a to the power of 5 times 3. So that is why this rule came up, that a to the power m and whole raised to the power n is equals to a raised to the power of mn. Then there is another important property in indices, that if you have a to the power of m and it is multiplied by another power expression, here the power expression is different, but exponent value is same. Like I have 2 raised to the power of 3 times 5 raised to the power of 3. So what I can do is, I can write it 2 times 5 raised to the power of 3, or I can write it a times b whole raised to the power of m. In the first index law says that the power expressions should have same basis, exponents can be different. Then these powers will be added. But here, powers are same, but the bases are different. In that case, they will be multiplied if there is a multiplication sign. And this power is a common power, so we will take it together. So here I can write it 10 to the power of 3. This rule is applicable for division also. If you have a to the power of m divided by b to the power of m, please try to differentiate it from a to the power m divided by a to the power of n. Here the bases are same, so we subtract the exponent values. But here the bases are different, so we can just write it a over b and whole raised to the power of m. Okay, this is a plus a. Next comes, so for example, if you have 10 to the power of 3 over 5 to the power of 3, I can write it 10 over 5 and whole raised to the power of 3. And we know that 5 ones are 5 and 5 twos are 10. So it is 2 raised to the power of 3, and which is 8. Okay, so this is another kind of law. Then comes a very important result, if you have a to the power of m plus b to the power of m, you cannot write it a plus b raised to the power of m. This is very important. This, if the power expressions are different and these power expressions are different in terms, the bases are different, powers are same, then you can combine them only for multiplication and division, but you cannot add them for plus or minus. Same way, if you have 8 to the power of m minus b to the power of m, I cannot write it this way. This is very important. I'm going to write all of these 4 rules again. If it is a to the power m plus b to the power m, we cannot write it like a plus b to the power of m. That would be completely wrong. Okay, and we cannot write a to the power m minus b to the power m as a minus b to the power. That is also not equal. But if you have a to the power of m multiply by b to the power of m, definitely you can multiply a and b and then take power as m. Or if you have a to the power of m divided by b to the power of m, you can take it a by b whole raised to the power of m. These rules are very important, very, very important. Clear? Next comes zero exponent value. Let's say you have 3 to the power of 0. That means there is no 3 in multiplication. It's just 1. If you take any number or any finite value, means which you know what is this value, and taking a power of 0 to it, this is always 1. If you take x to the power of 0, that is also 1. If you take y to the power of 0, that is also 1. 3z raised to the power of 0 is also 1. 1 over 4 whole raised to the power of 0 is also 1. 1 by 2y square whole raised to the power 0 is also 1. So any finite value, if you take its power 0 is 1. Let's say a very complicated expression is written 2x square y 3x plus y and then whole square and then whole raised to the power 0. This is always 1. If the whole exponent value is given as 0, so whatever is written inside, you have no need to even calculate it, just write that it will be 1. Then comes negative exponents. Negative exponent values. To understand this concept of negative exponent value, please watch the next lesson, which is going to come very soon. Thank you.